Hello folks, welcome to another day here at the bench. So, warning, it's a genuine warning to you. This video is going to be exceedingly boring. So if you have accidentally found yourself here by some quirk of the famous algorithm, immediately press the stop button, go up to the search bar, type funny cats and press enter, and you will be safely taken away from this nightmare. Don't say I didn't warn you. For the 3 people that want to stay with me, we are going to be looking today quite in depth at how to go about programming a BMW i3 LIM module that you just purchased from your friendly BMW main dealer. This programming needs to be done to a LIM that is purchased new from a dealer, because it does not, by its very nature, because it's new, contain any information about its intended vehicle. And the problem there is, if we attempt to use that LIM without having that data entered into it for a conversion project for CCS fast charging, it will not work. So this coding procedure here is what we are going to demonstrate to you today. We're going to get in depth with the software, where to get it, and also the hardware and where to get that. And there'll be a series of links in the video description that will show you where to get most of these things. So, what I'm also going to be doing here is I am attempting to log the CAN messages that are needed to, the CAN messages exchanged between the BDC and the LIM during the coding procedure. If I can achieve that and isolate what those CAN messages are, we'll then be able to publish that data so that people will be able to code their own LIMs with just CAN. So you wouldn't need any of this kind of stuff that you see here and that we will be detailing for you shortly. So I'll stop talking and I'll get into the hardware first, and then we'll go on the computer there and we will show you, I guess, how the software side of things works. It's not a particularly difficult process now that I've done it a few times here on the bench, but when I first tried this I hadn't a clue, and I had to get 2 extremely knowledgeable people to assist me. I'm not going to name them, but you know who you are, and thank you very much indeed for your kind assistance. So, yes, that's about it, folks. I will get into the meat and potatoes of this, and we will see you on the flip side. Okay, so let's give you folks a bit of a walkthrough here to what we actually need on the bench in terms of hardware for communicating with and coding our LIM. So you'll see 2 LIMs here on the bench. This LIM here is one of mine. This one was purchased second hand. You'll see that I've done some mods to it for development work, but it's a perfectly functional LIM. And this would have been coded to whatever vehicle that it was removed from by the breaker, wherever I purchased it from. I've forgotten at this stage. This LIM is brand new, straight from a BMW main dealer. I have the receipt here for that. I don't want to show it on camera because there's just a lot of personal, potentially personal data on there, like bank details and that. So, but what I can tell you is the total price all in for that LIM was €224.39. So that is brand new, just from a main dealer, walk-in price, no discounts or anything. The best of my knowledge, it was a friend of mine purchased this, asked me to program it. So, obviously, we're going to need a LIM from, see, a brand new LIM. I guess the question is, I'll just answer this a couple of times to try to help people, is why do we need to do coding on this? Well, the reason is that when these modules are sold new by a main dealer, they are blank from a perspective of information about the car. So what kind of options, for example, that the car has that they're going to be installed in. And that makes sense from the main dealer's point of view, because then they can simply program the module to work with that particular vehicle. So this LIM here, for example, would have specific coding on it for whatever, whatever particular, it's hard to describe, whatever particular options, I guess, that this i3 had, whereas this one is an absolute blank slate. So what we're going to do is give this some info, and that will then allow it to work as a CCS and general charge port controller in our EV conversion project. So enough waffling. What do we need? Well, it's not that complicated at all. The first thing that we're going to need is this kind of a white box here. Let me just turn the power off here, so I'm going to move some stuff around. So let's try and get this in better shot for you here. So the first thing we're going to need is this white box here. And this is called a BDC, which stands for a body domain controller. And this is basically the main electronic control unit, or ECU, out of a BMW i3. And this decides all of the communication buses in the i3 come back and leave this module. And more importantly even than that, this module, because it came from a, this was not purchased new, this was purchased from a accident damaged vehicle. So this contains the FA, or vehicle order, which we were talking about. And that vehicle order that's stored in here is what we're going to transcribe to the LIM. So that basically, as far as our little bench setup is concerned here, this is an actual i3. So we're going to code this LIM to this BDC. So in order to do that, we need to be able to communicate with the BDC. In order to do that, we need this little bit of wiring harness here, which is called a FEM BDC test platform. So what this is it's just a little box really, with some convenient wiring plugs coming out of it. And most importantly, it has the induction loop in here for picking up the chip that's in the car key. So this is the key, or at least one of the keys, for this car. So this BDC and this key must come from the same car. So that when we power this whole thing up, the BDC can see the key here and can basically switch the car on, and then allow us to communicate not just with the BDC, with the LIM, and indeed any amount of modules that we would wish to have here and communicate with. So this particular one, again there'll be a link in the description to this, is called a GODIAG, G-O-D-I-A-G, BM Key Pro Adapter. There's just two multi-plugs that connect to the BDC, Con 8 and Con 7. And there's a little spade terminal that connects. I think this would be where the main battery supply would connect to the BDC. We need to take our car key. Now it doesn't, fit in here. I think this is designed for a different type of a key, but I found that just leaving it sitting there on top of the thing works. The next part of this is on the back of this. Let me unplug this and show you. It'll be just easier that way. So on the back of this module, there's a 25-way D socket. And on here, we have a 25-way D plug. We're going to plug that in there. The red and the black wire, you want to supply 12 or in this case 14 volts DC. This had a barrel connector on it, so I just cut that off just so I could use a bench power supply. You could use, say for example, a 12 volt car battery with a battery charger on it as well. I find this whole setup here, when it's powered up, draws about 700 milliamps. Coming out of the 25-way D here, basically we get a standard OBD2 socket. And onto that OBD2 socket, we need to connect a Ethernet cable. There'll be a link in the description where to get that guy. So that plugs in here, the key goes in here. And so now the next question is, how do we connect the BDC to the LIM? And what connections do we need? Well, it's actually quite simple again. In Con 8 here, they don't populate these. Well, I believe, memory serves me now, it's pin 46 and pin 47 are PT can high and PT can low that we need to bring out from Con 8. And we need to connect those. You'll see this little twisted pair here, a red and a blue wire, and they connect then to a white and a blue wire that gives us can high and can low connected to our LIM. So we need can high and can low to the LIM, and we need power to the LIM. So you'll see here, we've got some wires coming across here. So we have our black and our red. Give us power to the BDC test rig, and also then we have these wires just bringing 12 volt power over to our LIM. And folks, that's it. This little Arduino Dewey here is just for logging CAN messages, because one of the things I'm trying to do here, just as I'm doing this coding stuff, is I'm trying to see if I can capture the actual CAN messages that are needed for coding one of these LIMs, because obviously it's not going to be practical for most folks to go out and buy, this test rig and BDC and a key and all this stuff just to program one LIM for their own conversion. So ideally what I'd like to do would be to be able to work out the CAN messages that are needed to, I guess, to marry, for want of a better word, a LIM to this BDC. I could then publish those CAN messages, and people would then simply need to power up the LIM and send the CAN traffic to it. You wouldn't need then any of this stuff here. But at the minute, I haven't gotten to that point. But what I will do, hopefully by the time you're seeing this video, I'll have done a few CAN logs here, and I'll post those up on the LIM GitHub page for you to peruse. So anyway, enough about that. So we need this Ethernet cable, and that will connect to your PC. Let me move the old up. Oh, there it is. Wow, top spec camera work. So over here, oh no, my top spec camera work is failing me. All right, let's come over here. Just try turning off that silly light there. It might make life a little bit easier on people's eyes. So over here, Our Ethernet cable has OBD2 obviously on this end, but it's got a standard Ethernet plug on this end. Let me just pop that. Well, okay, it doesn't want to just pop out of there. Of course it doesn't. Out, just a standard RJ45. I decided to use a USB to Ethernet adapter just so I would have a dedicated Ethernet connection for what I'm doing here. But I would guess there's no need for this. I would guess you could just connect it straight to the Ethernet port on a laptop or a desktop PC. But as I said, I just went for that option there. I happen to have it. So that's how I did things. So folks, that's the hardware side of it here. I'll just power it up just very quickly for you here. Oh no, my top spec camera work is failing me again. Right, so let's power it up. And we see we get a, basically it's like LED city here. There's a green LED coming off the back and there's more LEDs on this, but that's it. It's drawn about 750 milliamps right now. And so what we'll do is we'll jump on the PC here. And I'll do a bit of a screen grab and we'll show you what happens when we initiate coding on this guy. Okay folks, so we're here on the desktop, well not the desktop, the laptop I suppose. So to run Esys, which is a software tool that we're going to use, we do unfortunately need a Windows operating system. This is Win 7 64-bit that I'm running here. So the first thing we're going to need to do is we're going to need to download Esys. So this web address here, I will link in the video description below for you. The version that I use is this 3.36.2 64-bit here. So we're going to go ahead, download and install that. I don't need to show you how to do that. That's all straightforward and I've already done it here on this computer, obviously. Next thing, we're going to need a data package for Esys. So we'll put this, again, this link here will be in the video description. And it's 4.36, if I remember, 0.12 is the one that I used. I'm not sure, to be honest, if it makes any difference here which of these data light packages that we use, but again, just for completeness, this is the one that I use. Now, this is a RAR package, so when we download this, we're going to extract it. And so what you want to do is install Esys first, then download this guy. And when it downloads, what you want to do is go to your C drive. There'll be a data folder here for Esys, and there will be this PSDZ data here, and we want to extract this PSDZ data here into this PSDZ data directory here in our Esys. And that's it. That is your Esys fully installed. So at that point, you can go ahead and you should have an Esys logo here. We can just double click that and it should pretty much load up for us. Is that a chopper? That's definitely a chopper. As long as it's not black. Anyway, so Esys will then load up. I can just OK this thing here. So when you first get it, it will typically be running in this comfort mode. Wow, that is definitely a chopper. Get to the chopper. Okay. Typical timing, right, when I'm making a video. Anyway, so it will typically be in this comfort mode here. So the first thing that we're going to want to do, you're going to want to hit expert mode tab here. Oh, of course you can't see that, because why would you do that? Really? Okay, brilliant. Okay, so this is not going to work, is it? Because this Gomi thing has decided that it doesn't want to show us the full screen here. So that's really helpful. Let me go ahead and fix that. Okay, now that we've that little problem fixed, what we want to do is, and at least the chopper is gone now as well, so there is that. So let's go to the expert mode tab here. So at this point, what I'm going to do is I'm going to power up the benchtop system here, which we have connected as per we showed. It's going to power this whole thing up here now, and it's a live Igor. So next thing we want to do here is we want to connect to our system. So there's a little icon up here with a kind of, I guess, two symbols connected with a cable and two arrows going back and forth. So we're going to click that. Okay. So we want to, this won't be quite set up this way for you when you first install the program. Typically this main series tab here will be set to all. You'll have all of the new and sexy BMW models that you can communicate to with Esys. So we're going to change this from all to I001, which is our i3. And we're going to go with this first option here, the not direct option. Again, this is probably not going to be set to connection via VIN, but you need to click this tab here for connection via VIN. You can hit a refresh on that if you wish, and it pretty much picks up the BDC's IP address here, and then we just hit connect. And we have a connection established. So now we have connected, and you'll see there's a green thing here, and you'll see the VIN of the BDC and the series of the car here down in this little tab as well. So we're going to come over here to the left, and in these kind of oscilloscopy type things, we're going to hit coding, like so. And it's going to bring up this window. We're going to come across here to this SVT actual box, and we're going to hit read ECU. And that's going to populate this window here. And basically this is giving us all of the ECUs, or electronic control units, that the Esys program can see. So at the minute it's seeing the BDC body, BDC gateway, which are part of the same box, and it's seeing our LIM, which is the LIM that we've just programmed. This is our new LIM that we've programmed here, and it is all blue. Now when you connect a new LIM here, these are not all going to be blue. Some of these will be in red. So in order to code this, what we're going to do is we're going to select LIM here, going to right click it, and you'll see there's a code, a little window pops up, and there's a code option here. So what this is going to do when we click on it, and we can put any LIM that we want into this system on the bench here now. What that's going to do is it's going to take the FA from our BDC and it's going to code the lim that we've attached to this FA. Now what does that mean in non-BMW lingo? Well, in BMW lingo, FA is, and I'm sure the experts out there now will tell me I'm a complete idiot, which of course I am. But in simple terms, as I understand it, the FA is kind of the list of what makes up that particular car. So this BDC is basically the car. This thinks that it's a BMW i3. So as I said, this is kind of like the Johnny Cash song. You know, the first day I got me a BDC body, the next day I got me a LIM and a REME module or whatever it will be to make this whole thing up. So because we have the main ECU, we have the guts of the electronic side of the i3. So when we hit code here, that's going to say, aha, it looks like Damien has just fitted a new lim to his BMW i3. Let's go ahead and make this lim, which won't be all blue here, let's make this lim part of this car. So I hope that kind of makes sense to folks. Yeah. Let's go ahead and hit that. We've already done it, obviously, but let's just do it anyway. Oh, we have to activate FA, which is kind of useful because I haven't done this, and this is what I had messed up on when I first did this. So let me just pause things there for a minute. Okay, so it would have been helpful if I'd came up here and actually hit read vehicle order. Okay, so now what we've done is we have read out the FA into Esys. So Esys now knows what kind of a car setup that we have, and you'll see there's a green active here. So now we can come down here and we can hit code, and it's going to do some cool things here, and it's going to do all of this kind of thing, and it's going to scrolly. And there's more scrolling and more acronyms that I don't understand, but write FA to VCM is one that I do understand. So VCM update finished. That's the kind of important one. I mean, I don't suppose we can maximize this crap, can we? But anyway, you should be able to see that here. VCM update finished is what we want to see. So even though I'm a complete idiot, we have managed to do this, and we'll basically see here deploy finished and CAFD such and such is finished. Action code error, it's very like NCS expert. So that's it, folks. That's what's needed from a point of view of installing Esys, installing the PSDZ data, activating FA, connecting to it, activate FA first, and then coding whatever module that we happen to have connected. In our world, we're only concerned about the lim. So that's it. You are done. You will now have coded the lim. So let's just clarify something here about what this actually means. So what this means is that the lim that we've connected here now is now part of this car. Okay, it's now part of the car that this BDC came from. Now, we don't care about things like the VIN and so forth, because as long as we don't send the LIM the wrong VIN, it will be perfectly happy to work in our conversion projects for us. So that's it. That's Esys. That's how to go through it. So yeah. Alrighty, so hopefully, having watched all that, you will be a little bit more informed about the procedure for coding, programming, whatever you want to call it, our BMW i3 LIM module, so that we can use it in EV conversion projects for the purposes of CCS, fast charging. So, a couple things to just wrap up with, because I know this is going to be asked. I am going to, in the short term anyway, offer this as a service for people. So check out the EV BMW web shop, where I will have that facility there. In the meantime, I will be, as I say, doing some CAN logs, and I will publish those logs most likely on the LIM GitHub page. There'll be a link in the description to that as well. So if you want to have a look through some of those logs from a point of view of figuring out what CAN messages are required, that would be brilliant. Obviously, in that sense, you know, I'm doing myself out of a potential income stream, but I'm not the kind of a person that likes to hold things to ransom or keep things closed. I'm trying to make the information as freely available to folks as I can. So that's about where things stand, and I will see you folks in the next semi-exciting episode. We've got some interesting drivetrain and Tesla Model 3 stuff coming soon for you. Until then, don't forget to dislike, do not share, do not subscribe, and for pity's sake, folks, don't support me on Patreon or PayPal, because then I'll take your money and use it to fund this kind of thing, and nobody wants that. So, until then, happy LIM programming.